Hello, it's your machine shop instructor here, Ed, from sunny Sarasota, Florida, teaching you live from the STC remote machining facility studios here with my trusty sidekick Sydney, who's off camera right now. I'm confused on what to teach here. I don't know what to teach. I got a Mastercam mug, an Autodesk hat, a Titan, a micrometer shirt, but I had this PowerPoint I've been working on. This is something I would use to lecture with, and I've been kind of building it for a while, but I might as well just make a video out of this thing. So how to set up a CNC slant bed 2-axis lathe. And we're going to talk about tool offsets and work offsets. And work offsets are a little bit different on the lathe. And pictured is a graduate of mine, Todd Lazelle. He's good friends of mine now. He's actually a soccer referee. It's pretty interesting. And he came from the financial industry, but wanted to learn machining. All right. So let's go page by page here. Let's see. Yeah. Page, I gotta find the page down button here. Jesus, I'm at a boss here. Page down, here we go. Here you go. Alright. The coordinate system on a 2-axis lathe has only got 2 axes, X and Z. So I like to say in the mill, this is like the drone view or a hovering view of the spindle, but in this case the Z-axis is going left to right, and the X-axis goes in this view up and down. We'll show you how it works on the lathe. Alright, this is our ST10 in the left corner here, and they all have to be homed out like we do at the mill. So the machine home position would be upper right corner. So Z would be all the way to the right, and X would be all the way up. This turret right here. This is what moves the turret in this head. And the spindle stays there. So unlike the mill, the part is always in the same place. And the tool moves, versus the table moving around on a mill. Alright, so when you're at the home position, everything's based off of machine coordinates. So this is the position page for machine coordinates. It's like one of the first things I learned about the coordinate system. Okay. How do you set them up? Different systems from CNC mill. The position settings are for the tools from the home to the part. Can be set with various probing methods. You could do the auto probe or manual probe touch-offs. The work coordinate system is the same on a Haas, uses G54, etc., but only uses to shift the Z-axis on the 2-axis. So it really, I think in FANUC controls they call it Z shift, so that's more applicable description of it. Alright, so this is the big picture position display right here. So you're at machine 0. These two on the right is work coordinate, which is relative to the part, and distance to go would be if you had an active program running. Operator is an independent view. I'll tell you, back in my old days, I think on some other machines they call this, I forget what they call it in the FANUC, but we used to get the numbers off the wrong. We were trying to make sure we always use the machine coordinate numbers. So this is really a user-only positioning display. Alright, so when you're in the tool geometry page, this is what you're going to get. X and Z positions from home to the part. So on that machine, always X negative and Z negative numbers. So we need to populate these columns. Also on the lathe, you're going to have tools that are out of order because they're usually in certain positions on the turret because it's the way somebody put them in, or they need to have like space between the tools. So Unlike a mill, we tend to run everything in order, like 1, 2, 3, 4, 5. On the lathe, we might be like 1 and then get 5 and then get 7. So a little bit different. All right. This is a probe tool touch-off example on our machine right there. And this is called position number 3, and I'll explain what that is. So on the lathe, the tools are, as opposed to like a conventional lathe, the tools are upside down, but the cutting direction is still the same because the spindle still turns the same direction. So here's the insert right here, and this is the position you have to put it in because you have to get the 2 coordinates, which would be X would be this way and this Z would be this way. Notice I painted this green once and it's got a bash mark there because that's from somebody trying to change, well, it actually happened a couple times. Somebody tried to change tools in that position. This turret will rotate wherever you have it, so you need to get it out of the way. We generally bring it back to the home position because the machine isn't that big. It doesn't take forever to get there, so bring it back to home, change tools, and then do what you got to do. So anyway, so in this example, here's the part, and what we're trying to do is align to the X and Z0 position. If we made the front Z0, and the center is always X0, it never goes anywhere. The only thing that can change is how long the part is. So if you're viewing it from the door, here's the probe, right? Swings out, and you're going to do this example up here and get those coordinates. So what it'll do is set the Z coordinate to where the probe is, and it's calibrated to find the X0 position. So that's what we're trying to do. All right, so this is actually, if the probe is the square corner was on this side, and you're doing a manually probe touch-off, which is using the jog button, not the jog hand wheel, and you would go beep in that direction, and that would get you your Z number. And then the same thing here, you'd be going beep in this direction, and this would be calibrated to know where X is. So it knows where this is, and it's going to make all the tools align to the center of the spindle. All right, this is the auto probe system. Okay, you see a lot of videos on it. Always run it in manual. Never have it in automatic, or it's going to change tools. And don't use the brake protection. Just use manual. This will be grayed out, because if that's the tool you have in there, you're not allowed to change the tool number. You can change the tool offset. Don't change the tool offset. And then it wants a tip direction. So if you press this button, this will rotate around here. It'll give you the orientation you want. And these numbers may or may not be correct. So you put it in that position right there. You got to hand jog it down. And you're not going to touch it. You're going to let the auto probe do everything. We used to do the F4 to record to a program, just like we did in the mills, and we decided to try to cycle start one day, and it works great, because then we can leave this page active all the time. So you put it in position, and you can, as long as you leave it in this, actually the hand jog is active. And you put it in match. You know, if you're trying to learn, you're trying to follow what I'm telling you, but this is telling you right there. Put it in that position, hit cycle start. It's going to go beep and then populate these for that tool number. All right. So that'll be most turning tools and grooving tools and cutoff tools are going to use this upper right or tip direction 3. Now this one is for drills, taps, and reamers, tools that are on center line. So you got to put it in this position, you call it 7, and it goes beep, and the only thing it sets is Z. X will not be set. But I've seen this on older machines where somebody wrote down the number of where all the center line tools are. But the Haas has this F2 to set center line, so this will actually put in the number that's on center. Use F2 to set X so that the drills are aligned to the middle of the spindle. just like you would if you were making like a spacer on the manual lathe. Boring bars. This is probably the other common ones of tip directions. Boring bars are internal, so they're in this orientation. So you got to use tip direction 2. And the same thing, it's going to go beep and beep and populate these numbers. Okay, so a little discussion about the tools. This is the 3 common tip directions. And this is actually a good picture of what it really looks like. This is an insert right here. There's always a radius on here. So what the probe is doing is finding where this tip would be touching right there and right there. So that's what it's doing. And additional tool setup data. Depending on how it was programmed, you may have to manually insert the tool nose radius, or TNR. This is a little discussion on tip direction. So most outside tools are tip 3, and that includes cutoff and grooving tools. I see people use the wrong one for a cutoff tool because it didn't look like the picture. It didn't look like that. You know, it's more about understanding how this works. So your boring bars will be this direction, your drills, taps, reamers will be this direction, and all your outside tools. So this is probably the most popular one by far. And then you have to enter in the TNR, the tool nose radius. So when you're doing the probe setup, tip direction 3 is the direction of the top of the square. Tip 7, drills, taps, and reamers. And if you use left-handed tools, you have to use a different orientation. But that's a little more advanced. And you need to manually enter the tool nose radius right up here. This column right here. If you're manually programming, you're definitely going to have to do this. These are typical. 1/64th. You got to put in a decimal, 15 thousandths, 16 thousandths. 1/32, you got to put in 0.31. Pretty much every insert out there has some kind of radius on it. Even they might appear to be sharp cornered, they probably have 5 thousandths or 3 thousandths radius. Cutter complement in the lathe works a little bit differently. If the part is too big on the outside, you don't comp the radius like you would on a mill. You change the X position. That'll make it bigger or smaller. And that applies to outside or inside. If something is too deep or too shallow, you'd play with the Z. But usually X is the one you're playing with a lot. And in this screen, this is the basic coordinate page. Now you can adjust the big number, but it's recommended to use the where column. Okay. Rent a sharp probe is expensive. Move the tool away before the tool change, which I stated before, because this is just going to rotate right there. Okay, we got the tool geometry screen, which we already talked about. We got radius, taper, you probably won't be using, and is where the tip directions are stored. All right, work offsets. Z shift only. Do not shift X position. If you're using the probing system, you need to measure the distance from the probe to the part. You can use one of the cutting tools to do that. Plus, you really should know how the shop does it. So, all right. So here is the X is always 0. Never shift the X, and wherever the part is compared to the probe. So if the probe is here and the part is here, you got to get this distance in here. You got to figure that out, so you're incrementally shifting it left or right, most likely left, unless you have a very long part. All right, so in this column here, you're not going to have anything in this column. You're just going to have a shift in the z-axis. Now, how do we do that? I didn't really get to this. I may have to add this in there. You take one of the lathe tools, probably like tool 1 or your basic OD cutting tool, outer diameter cutting tool, and you go turn the spindle on and you bring this up and just skim the front of your part. And you got to put it in the correct stick out length. You need to know your stick out length. If you need to make something a certain length, this is what we learned on manual lathe. You need to be able to put it in a certain distance from where it's clamped. So you put it in stick out length, and then you turn the spindle on, and you can do this with the door open, running low RPM on the classic controls. I'm not sure about the next gens. And you just want to skim touch the front here. And when you do that, you press the Z face measure button, or you just do the math, from where the tip was and where it is now. I use that as a test of look at the machine coordinate now and look at the machine coordinate that was used to set that tool. So in this case, you'd be adding more negative direction, kind of like, where's that screen I had? This one here. So if you touch the front, you hit the Z face measure button, and it should populate this number in here. But I wanted to show people where the number came from by looking at the machine coordinates. Okay, so that's it for lathe setup school and how to set up tool offsets, and then we'll get, but the more knowledgeable you are in this and you watch some of the videos of how it's actually done, which we have in our system, or the Mark Terryberry's tips of the day, there's plenty of learning on that. Okay, and thanks, and have a nice day.